Our topic is pumps. Pumps are used to transfer and distribute liquids in various industries. Pumps converts mechanical energy into hydraulic energy. Electrical energy is generally used to operate the various types of pumps. Pumps have two main purposes: transfer of liquid from one place to another place, example water from underground into water storage tank. Circulate liquid around the system, that is cooling water or lubricants through machines and equipment. The components of a pumping system: pump casing and impellers, prime movers, electric motors, diesel engine or air system, piping used to carry the fluid, valves used to control the flow in the system, other fittings, controls and instrumentations, end use equipment which have different requirements, example pressure, flow, and therefore determine the pumping system, the components and configurations. Example include heat exchangers, tanks and hydraulic machines. Classification: there exists a wide variety of pumps that are designed for various specific applications. However, most of them can be broadly classified into two categories as mentioned below. One is positive displacements and dynamic pressure pumps. So the pumps we can categorize into dynamic pressure pumps, positive displacement pumps. The dynamic pressure pumps classified into centrifugal pump, propeller pump and turbine. The positive displacement pump, reciprocating pump and rotary pumps. So the reciprocating pump, piston and diaphragm type, whereas rotary pump, gear, lobe, screw, vane and rotary plungers. So the positive displacement pumps, the term positive displacement pump is quite descriptive because such pumps are designed to displace more or less fixed volume of fluid during each cycle of operation. The volumetric flow rate is determined by the displacement per cycle of moving members, either rotating or reciprocating, times the cycle, the example RPM. The flow capacity is thus fixed by the design, size and operating speed of the pump. The pressure or head that the pump develops depend upon the flow resistance of the system in which the pump is installed and is limited only by the size of the driving motor and the strength of the parts. Consequently, the discharge line from the pump should never be closed off without allowing for recycle around the pump, or damage to the pump could result. They can further classified into types of positive displacement pumps, that is reciprocating pumps. The pumps takes place by to and fro motion of the piston or diaphragm in the cylinder. It is often used very relatively small quantity of liquid is to be handled and where delivery pressure is quite large. Piston pump. A piston pump is a type of positive displacement pump where high pressure seal reciprocates with a piston. The pump has a piston cylinder arrangement as the piston goes away after the delivery stroke. Low pressure is created in the cylinder which opens the suction valve on forward stroke. The fluid filled inside the cylinder is compressed, which in turn opens the delivery valve for the delivery of liquid. So this is a piston pump. So the diaphragm pump uses a combination of reciprocating action of rubber, thermoplastic or Teflon diaphragm and suitable non-return check valves to pump a fluid. Sometimes this type of pump is also called membrane pump. Then rotary pump. So in rotary pumps, the relative movement between rotating elements and the stationary element of the pump cause the pumping action. The operation is different from reciprocating pumps, where valves and the piston are integral to the pump. They also differ from centrifugal pumps, where high velocity is turned into pressure. Rotary pumps are designed so that the continuous seal is maintained between inlet and outlet ports by the action and position of the pumping elements and close running clearance of the pump. Therefore, rotary pumps don't recommend valve arrangement similar to the reciprocating pumps. This gear pumps. So gear pumps uses meshing of gears to pump fluid by displacement. There are one of the most common type of pumps for hydraulic fluid power applications. The rigid design of the gears and house allow for high pressure and the ability to pump high viscous fluids. Then low pump. So low pumps are similar to external gear pumps in operation in that fluid flows around the interior of the casing. As the lobes comes out of mesh, they create expanding volume on the inlet side of the pump. Liquid flows into the cavity and is trapped by the lobes as they retreat. The liquid travels around the interior of the casing in the pocket between the lobes and the casing. Finally, the meshing of the lobes forces liquid through the outlet port under pressure. Screw pump. These pumps are rotary positive displacement pumps that can have one or more screws to transfer high or low viscosity fluids along an axis. Although progressive cavity pumps can be referred to as a single screw pump. Typically, screw pumps have two or more intermeshing screws rotating axially clockwise or counterclockwise. Each screw thread is matched to carry a specific volume of fluid. So, screw pumps provide a specific volume with each cycle and can be dependable in metering applications. So, vane pumps. A rotary vane pump is a positive displacement pump that consists of vanes mounted to a rotor that rotates inside the cavity. In some cases, these vanes can be variable length and or tensioned to maintain contact with the walls as the pump rotates. Rotary plunger pump. The pumping action takes place by rotating rotor and a rotating plunger. In a rotary pump, the axes of the plunger are perpendicular to the rotational axis of the rotor or at an angle of not less than 45 degrees to the axis. The rotor is located eccentrically with respect to the axis of the case. Suction and forced delivery of the liquid occur with the reciprocating motion of the plungers as a result of centrifugal forces and spring action. Rotary pumps of this type may have as many as 72 plungers arranged in multiple rows, provide a delivery of Q less than is equal to 400 liters per minute and build up pumping pressure rho less than 100 meganewton per meter square. Dynamic pressure pumps. In a dynamic pressure pump, during pumping action, tangential force is imparted, which accelerates the fluid normally by rotation of impeller. Some systems which contain dynamic pump may require positive displacement pump for priming. They are normally used for moderate to high discharge rate. The pressure differential range for this type of pump is in the range of low to moderate. They are popularly used in a system where low viscosity fluids are used. And centrifugal pumps. They use a rotating impeller to increase the pressure of the fluid. Centrifugal pumps are commonly used to move liquids through the piping system. The fluid enters the pump impeller along or near the rotating axis and is accelerated by the impeller, flowing radially outward into different or volume chamber from where it exits into the downstream piping system. Centrifugal pumps are used for large discharge through smaller heads. These types of pumps are used for supply of water and handling of milk and dairy plants. So propeller pumps. A propeller pump is a high flow, low lift impeller type device featuring a linear flow path. The propeller pump may be installed in a vertical, horizontal or angled orientation and typically its motor situated above the water level with the impeller below the water. These pumps function by drawing water up and outer casing and out of the discharge outlet via propeller blade. Propeller bladed impeller head.